Good afternoon, everyone. I would like to introduce the topic, which is dealing with computer tomography. Basically, it's the same idea as with the surface texture of the previous project. We will use the materials in the class of quality, which is held in summer semester, and we are thinking more about the blended form of the course. Of course, the materials will be available online from both of these projects, but if possible and if the students have the interest, we would welcome them also to the laboratories, because important part of the quality class is connected to our metrology laboratories. So this project is basically investigated by me and my colleagues, which are here described. And what is the idea behind the project? It's about to introduce the technology of computer tomography and show some typical applications which industry requires today inside their quality inspection processes. So the first in mind is dimensional inspection, then, for example, analysis of composite materials, separation of fibers, matrix, orientation of the fibers, and then, of course, porosity of castings or porosity of injection molded parts. So all these analyses have their specifics, so we will try to prepare the source data, meaning a point cloud. In this case, we are speaking about really big data. We have to prepare some storage, actually, for the data, so the students can download the raw data and the templates where the evaluation will be done. So we will basically guide them step by step how to get from raw data to analysis that is required by today's market, I would say. So we will explain the physics behind the computer tomography, how the X-ray is generated, how the acquisition of the data is provided on the CT. We will also mention about the fixturing, which is quite atypical for these applications, because X-ray basically sees the materials based on their density. So you are also searching for the fixtures which are very low density, so they don't affect your imaging, and so on. And here is some simple case to introduce the CT. What does it mean non-destructive testing? What does it mean the analysis of internal, for example, assembly? Here you can see the Kinder Surprise egg, and here you can see that you can really analyze different layers of it. You can separate chocolate polymers because it has different density, and you can see inside without destroying it. And of course, when you destroy it, you will find out the same thing inside. So this is just a really easy data to explain, but what analyses are required today? Typically, for casting and injection molding, you are searching for the defects from the process, so you are searching from the porosity. Because the CT we have is also a calibrated metrology machine. It may measure, as a traditional coordinate measuring machine, dimensions, form tolerances. Because it recognizes different density, you can do multi-material analysis, meaning you can separate different materials in total assembly based on their density. Very quick analysis is when you have the nominal data, typically the CAD model, and then the actual part. In this case, this is a blade disc which was 3D printed. You can very quickly analyze deviations from the original data. Regarding the composite materials, this is basically a fiber orientation. Here in some kind of sample from Faculty of Civil Engineering, which was basically a concrete with steel fibers, or we can call it steel wires. They call it composite material, and it's composite material in that sense. So this is how you can, for example, describe the orientation of the fibers inside the composite. Or you can study complex internal structures which are typical for 3D printing, like lattice structures and so on. So we will prepare all these examples, and by the end of the year, I hope we will at least partially try to integrate it within some VR tour we already have for the laboratory. So the VR tour is basically, it works like a Google Maps. You can move around the laboratory within your, basically, Google Chrome or whatever Explorer you are using, or whatever browser you are using. And the only thing we have to do, maybe only, we have to fill it with the content. So now it's like a dead image, but of course we will prepare, there is some setup station, there is the computer for data acquisition, there is the machine itself, so we will try to prepare the guide if you are doing specific application, so you know the process and the workflow step by step. So this is the idea behind the project. I hope it will be done or finished by the end of this year. Thank you for your attention.